Hello everyone. Today, we will be going to show you some of the divisibility rules that we had discussed in one of our subjects, number 3. In this video, we will be going to present to you 3 different divisibilities, and that is divisibility by 3, divisibility by 9, and divisibility by 11. In this video, we will be going to present to you how to prove each divisibility rules. To start with, let's begin with divisibility by 3.
First, we have divisibility by 3. Rule for divisibility by 3, if the sum of the digits of a given number is multiple of 3 or can be divided by 3, the number is divisible by 3. We have the original number such that n is equals a sub n times 10 raised to n plus a sub n minus 1 times 10 raised to n minus 1 plus a sub n minus 2 times 10 raised to n minus 2 plus plus a sub 1 times 10 plus a sub 0. Then let S be the sum of the digits. S is equals a sub n plus a sub n minus 1 plus a sub n minus 2 plus plus a sub 1 plus a sub 0. Then n is equals a sub n times quantity of 10 raised to n minus 1 plus a sub n minus 1 times quantity of 10 raised to n minus 1, then minus 1 plus plus a sub 1 times quantity of 10 minus 1 plus quantity of a sub n plus a sub n minus 1 plus plus a sub 1 plus a sub 0. Each of the term a sub n times quantity of 10 raised to n minus 1, comma, a sub n minus 1 times quantity of 10 raised to n minus 1, then minus 1, comma, a sub 1 times quantity of 10 minus 1 is divisible by 3. Divisible Therefore, if S is divisible by 3, then N is divisible by 3. Let us examine some examples. We have 3, 2, 4. These numbers have 3 digits, and what we are going to do is to add the digits. So, we have 3 plus 2 plus 4 is equals 9. And since the sum is a multiple of 3, meaning when we multiply 3 by itself, we can get the product of 9. So 3 times 3 is 9. So 9 is multiple of 3. Therefore, this number 324 is divisible by 3. To further understand this, let's examine some example. Example, Consider the number 4368. 4368. Let us expand this number as a given below. We have 4368 is equals 4 times 1000 plus 3 times 100 plus 6 times 10 plus 8 times 1. Then we have 4x quantity of 999 plus 1 plus 3 times quantity of 99 plus 1 plus 6 times quantity of 9 plus 1 plus 8 times 1. Then we have quantity of 4 times 999 plus 3 times 99 plus 6 times 9 plus quantity of 4 times 1 plus 3 times 1 plus 6 times 1 plus 8 times 1. Then quantity of 4 times 999 plus 3 times 99 plus 6 times 9 plus 4, quantity of 4 plus 3 plus 6 plus 8. Then we will get the sum of 4368. We know that 999 are divisible by 3 and thus the multiples of these numbers are also divisible by 3. So, the divisibility of 4368 is now dependent on the sum 4 plus 3 plus 6 plus 8. Here 4, 3, 6, and 8 are the digits of the 4368. From the above, we can say if the sum of these digits is divisible by 3 or a multiple of 3, the number 4368 is divisible by 3. Hence, we can conclude that if the sum of the digits Hence, we can conclude that if the sum of digits of a number is divisible by 3 or multiple of 3, the number is divisible by 3.
Next, let's move on to the divisibility rule by 7. The divisibility rule of 7 states that if a number is divisible by 7, then the difference between twice the unit digit of the given number and the remaining part of the given number should be a multiple of 7 or it should be equal to 0. The number n is divisible by 7 if any number where absolute difference between twice the unit's digit and the number formed by the rest of the digit is 0, or divisible by 7 is itself divisible by 7.
proof. N is equal to a sub n times 10 raised to n plus a sub n minus 1 times 10 raised to n minus 1 plus a sub n minus 2 times 10 raised to n minus 2 plus plus a sub 2 times 10 raised to 2 plus a sub 1 times 10 plus a sub 0. Where a sub n minus 1, a sub n minus 2, a sub 2, a sub 1, and a sub 0 are integers. Let S be equal to a sub n times 10 raised to n plus a sub n minus 1 times 10 raised to n minus 1 plus a sub n minus 2 times 10 raised to n minus 2 plus plus a sub 2 times 10 raised to 2 plus a sub 1 times 10. Where S is the remaining part of the given number. The remaining part of the given number. So n minus S is equal to a sub 0 double the last digit of a number, which is a sub 0, the difference of n minus S, then subtract it from the remaining part of the given number, which is S. Therefore, n is equal to quantity a sub n times 10 raised to n plus a sub n minus 1 times 10 raised to n minus 1 plus 10 sub n minus 2, plus a sub n minus 2 times 10 raised to n minus 2 plus plus a sub 2 times 10 raised to 2 plus a sub 1 times 10 minus a sub 0 times 2. If the result is 0 or any number which is a multiple of 7, then the original number n is also be divisible by 7. For example, using the divisibility rule of 7, find out if 2,415 is divisible by 7. So let us apply the divisibility rule of 7 to 2,415 to check whether it is divisible by 7 or not. Step 1, multiply the last digit, which is 5, by 2. So the product is 10. Step 2, subtract the product 10 from the rest of the number, which is 241. 241 minus 10 is equal to 231. So in 231, we do not know if this number is a multiple of 7. So let us go back to step 1 with the number 231. So, repeat the process. Multiply the last digit of the number, which is 1, by 2. So the product is 2. Subtract 2 from the rest of the number, which is 23. 23 minus 2 is equal to 21. So 21 is divisible by 7. So we can conclude that the original number n, which is 2,415, is divisible by 7. Another example. Using the divisibility rule of 7, find out if 3,216 is divisible by 7. 3,216. Step 1, multiply the last digit, which is 6, by 2. 6 times 2 is equal to 12. Subtract 12 from the rest of the number, which is 321. 321 minus 12 is equal to 309. So we do not know if 309 is a multiple of 7. So let us go back to step 1 with the number 309. So multiply again the last digit by 2, which is 9 times 2 is equal to 18. Subtract it from the remaining number, which is 30. So 30 minus 18 is equal to 12. So 12 is not a multiple of 7. Therefore, the original number 3,216 is not divisible by 7.
And lastly, let's proceed to divisibility by 11. In this divisibility, note that the number n is only divisible by 11 if the absolute difference between the sum of digits in its even positions and the sum of digits in its odd positions is 0 or 11 is divisible by 11. So let's prove this one. N is equal to a sub n times 10 raised to n plus a sub n minus 1 times 10 raised to n minus 1 plus an minus 2 times 10 raised to n minus 2 plus dot 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 plus a sub 2 times 10 raised to 2 plus a sub 1 times 10 plus a sub 0. So taking the divisibility by 11 of n, we get n is equal to a sub n plus a sub n minus 1 plus a sub n minus 2 plus dot 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 plus this is a sub 2 plus a sub 1 plus a sub 0. In divisibility by 11, we have two cases. That is, n is even, so we'll put here n is even. Here we have here, for example, we have here n is even, and then n is odd. So here we will assume that if n is even, then 10 raised to n is equal to positive 1 since n is even. And if n is odd, then 10 raised to n is equal to negative 1 since n is odd. And then first, suppose that n is even, then we have n, we will only this is a continuation of this, okay? So we have here, if n is even, then we have n is equal to a sub n minus a sub n minus 1 plus a sub n minus 2 minus we have dot 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 plus a sub 2 minus a sub 1 plus a sub 0. So we will going to equate this one. We have a sub n plus a sub n minus 2 plus dot 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 plus a sub 2 plus a sub 0 minus a sub n minus 1 plus plus a sub n minus 3 plus dot 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 plus a sub 3 plus a sub 1. So we are going to we regroup this in this process. We regroup this since this is even and this is odd. All of this is even and then this is odd. Okay. So if the result is 0, this one, if the result of this 2 is 0 or any number which is multiple of 11, then the original number n, this one, is also divisible by 11. Okay, so note that this is again even, and here is even. Okay, so next we'll proceed to when n is odd. So we suppose that n is odd, then we have here when n is odd, then we have n is equal to negative negative a sub n plus a sub n minus 1 minus a sub n minus 2 plus dot 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 plus a sub 2 minus a sub 1 plus a sub 0. So this is equal to, we'll regroup again. This is a sub n minus 1 plus a sub n minus 3 plus dot 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 plus a sub 2 plus a sub 0 minus a sub n plus a sub n minus 2 plus dot 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 a sub 3 plus a sub 1. Okay, so here, if the result is 0, the result of this one, if you get the difference, if the result is 0, any number which is a multiple of 11, then the original number n here is also divisible by 11. So to further understand this, let's prove some examples. For example, prove that the number 135,564 is divisible by 11. So to solve this one, since divisibility rule by 11 states that we will get the absolute difference between the sum of digits in its even positions. So we will get even positions first, and the sum of digits in its odd positions is 0 or 11. We can say that it is divisible by 11. So we will get first the sum of the even digits. So we have the even is we'll have here so the absolute value of the even first. Okay, so we have here 3 here 3 plus 5 plus 4 minus 1 here. We will minus now the plus 6 minus now the odd. Okay, so getting the absolute value of it. So this is 3 plus 5 plus 4. We have here this is 3 plus 5 is 8 plus 4 is 12. So 12. Minus the 1 plus 5, the odd. 1 plus 5 plus 6 is also 12. So getting this one, we have 0. So since this is equal to 0, therefore the number 135,564 is divisible by 11. So there, we put there, it is divisible by 11. So there you have it. We hope that you learned something. Thanks for watching.